Before continuing, if you haven't watched the first part of this video, I would like you to do the same by clicking on this link right here, where we have discussed how we can create series and data frames using Pandas library, how we can use dictionaries to create those data frames, and some basic methods to change the indexing and sort the values inside those data frames. Okay, so let's get started with this video. In this section, we will see what are the most used methods in Pandas that we use for data analysis and manipulating the data for data pre-processing. Okay, so now instead of creating our own data set, I'll use already created data set, which I'll provide in the video description below as well. And now in order to import this data set, I'll just use pd.read csv command, and then I can provide the file name. So a CSV file is nothing but a file that is all the values are stored in an Excel file where all the values are separated by commas or a space. So in most of the projects, you'll also get these type of data set beforehand. So if I just print this data frame, you see we have different column headers for different columns. And since we don't have any customized row indexes, this is the default row index that we already saw before. Okay, so now we have 891 rows and 12 columns in our data set. If you also want to see columns separately, you can use dot columns method that we have already seen. It will show you different columns of our data set. Now the first and foremost thing that we do whenever we get a data set is to get a summarized info of our data set. So a dot info command, what it will do is it will give you the different columns that are available, what are the number of values inside those columns. So if the value is less than the maximum value, that means the remaining values are actually the null values inside our data set. Then what are the data types of each of the columns. Now from this you observe that in data frames we can use multiple data types, but in series we can use only single data type. Okay, so now let's us see some of the values inside our data set. So for that we can use dot head method. So it will give you starting 5 values from the upper section. So it will start from row 0 and it will give you the 5 values if you want to see. And if you want to see some more or less values, you can give your own number. Let's say if I want to see 15 rows instead of 5, I'll just provide number 15 and it will just show me first 15 rows of my data frame. And similarly, if I want to see the values from down below, then I can use a dot tail command and it will give me the last 5 rows of my data set. And if I just say that I want to see last 10 rows instead of 5 rows, it will show me the last 10 rows. Okay, so this is another function that you can use. Apart from it, if you want to see the statistical properties of the data, you can use dot describe command. Now whenever you use this, it will give you some of the values of the statistical properties, which will be the count of the data, the mean, the standard deviation, minimum, maximum, and all the quartiles of my data set. So this you can use whenever you want to see the distribution of the data, or if you want to scale the data, you can see what is the range of the data from minimum and maximum, and based on that you can decide if you want to scale the data or not. Okay, so this is another function that we have to check the distribution. Now if you observe, the distribution is always there for numerical data values. So if you see, we have columns which are both numerical, which is the integer and float types, and the categorical data, which is the object data type, and we can't have description of those object data type values. That doesn't make sense. All right, so let us see what we can how we can check those values of categorical data. So let's say cabin is one of the categorical data, and if I want to print the first value of it, I'll show you step by step. So if I just print df cabin, it will give me the whole column, and you see there are categorical values inside this data. And if I want to just get the first row of it, I can just again index this particular obtained object, and then I can just use dot the 0th index of this, which is the not a number, so that means it's a null value. Okay, now you can use it for other columns as well. So if you observe, we have columns like let's say gender. For gender we have this sex column, and if I just use this variable here and I just print let's say instead of printing just one row I want to print starting 15 rows. Okay, so it will give me the starting 15 rows of my this gender column. Okay, that's great. Now if you want to see what is the count of these categorical values, so if you want to see what are these what is the distinct values in this particular column, then you can use again fed out this particular column, and then you can use this unique command. So it will give you all the unique values inside this column. So instead of cabin, since cabin has a lot of different categories, let's use the gender column, and you'll see that this will give me that we have only two categories inside this column, which is male and female. And if I want to count the number of people inside each of the category, now I can use dot value counts function, and it will give me the count of the male and female in the data set. And if I also want to select the maximum or minimum, I can just use these statistical methods on these value counts, and it will give me the maximum number of count that was observed for this particular column. Okay, so this is how you can view your data in different ways. Also, one thing I forgot to mention is whenever I used this .info command, you'll see that we had some null values inside our columns, and if I want to see the null values, I can use .isNull method. What it will give me, it will give me a binary output with all the values as true wherever we have null values, and if we don't have null value there, it will give me a false value. Then I can apply a .sum function onto this, which will give me the sum of the count of the number of null values. So if you observe, we had three columns which didn't have the maximum number of values. So age has 177 null values, cabin has 687 null values, and embarked has just 2 null values. Okay, so let's say now if I want to change the values inside my data frame, so I'll just use this cabin column and I'll use the 0th value. Since it was a null value, I want to change this value to a particular cabin. Let's say I want to change it to the cabin number G8. Now if I do that, there is some warning which you can ignore right now, but if you see that if I print this particular value now, okay, so this value is be updated from NaN to G8. Okay, but we also see there is a particular warning that we are getting, which is setting with copy warning. Let us understand why we are getting this warning. So if I, let's say, create a new data frame from my original data frame, and then I apply the same operation on this particular new data frame. So I'll just change it to df2, and so let me show you first this particular command what it does. So this already has G10 into it, so we don't see any change. But if I change it to G12, you'll see the new data frame value has been changed to G12. Now if I also print the original data frame value, there is one interesting thing that you will notice, that value in the original data frame also changed. And why is that so? I mean, we created a new variable and then we changed value in the new variable, but the variable value of the original data frame also changed. It is because that whenever we use this operator or assignment operator equal to operator, it doesn't assign the whole data frame to a new memory block of df2. Instead, df2 just becomes a pointer to the memory inside where the data frame of original df value was stored. Okay, so wherever the value for df was stored, a df2 is just pointing to that memory block, and it doesn't have created its own memory block. So whenever we change anything in df2, everything will change in the original data frame as well, because it's pointing to the same memory block. So in order to avoid that, what we do is we do a dot copy function. Now if I create this, will create a new memory block for the data frame 2 as well. Now if I change it to G13, you'll see the original value is still G10 for df kbin 0. Okay, so that is one thing you should remember. And with respect to this only, we can understand the warning. So whenever we are actually indexing our data frame to enter some value inside that particular place, what we are doing is we are indexing the data frame two times. So I can just separate the indexing into the first indexing that we are doing, which is we are taking the kbin column, and then whatever the in middle data frame that we got, we are creating a new data frame using the zero indexing. Okay, so this thing I have broken down it into this two steps. So this is also called chain indexing that we do. Okay, so I have created a chain of the indexing that I need. Okay, and this is giving us warning because whenever we, let's say, index this particular value, it may happen that this particular value is a pointer to this memory, and then its index is also a pointer to this memory, and then the value that we are changing is actually changing the value in the original data frame. But sometimes what pandas can do is it may, instead of creating a pointer to that memory, it creates a new copy of the data frame. So what will that do is, in between this indexing, somewhere there will be a new data frame which will be created with the new memory block, and that particular data frame will be updated with this particular value, while the original data frame value will still remain the same. That's why it is always gives us the warning that we should not do this chain indexing method, as it may create some error and we could not identify this error in a big complex code. So instead of doing this chain indexing, what we generally do is we use two methods. So what we can do is we can use df.loc method. So this is the location method, and instead of indexing, I am using this location method where the first value is the row value that I want, which is the 0, and the second value is the column value that I want. Okay, so which is the kbin right here. So now if I let's say update it to G11, you'll see the value has been updated without any warning because we haven't used any chain indexing, so there is no scope of any error right here. So now if I just print df, let me just print this right there, so it will show you the value has also been updated in my data frame, which is now G11. Okay, so this you understood, I hope, and this is the warning, and you should avoid using this chain indexing method whenever you are updating the data frame. You always use .loc method whenever you want to fetch or manipulate the data in a particular data frame. The other method that I was talking about is to use ILOC, which is just the integer location that we can use. So in this I can just provide the integer for row and column as well instead of providing the actual name. So let me see. So this is 0 if I provide, this is the first row, and if I provide 2 in the column, this will give me the third column in my data frame. Okay, so this is the value in my data frame. Now if I want to print this same value, so I know that the row value is 0, and I want to see what is the column index value for this particular kbin. So for that, if I just go upwards, I'll see this kbin column is on the 10th index, right? So I can just replace that value with the 10, and you'll see that it will show me the kbin value at the first location, which is G11. Okay, so these are the two methods that you can use to manipulate the data and avoid that chain indexing method. Okay, next, if you want to delete a complete column inside your database, you can use .drop command, where you can just define which column you want to delete. So let's say I want to delete ticket column. So in this data set we have a ticket column, and I need to provide on which axis it lies. So this is on the column axis, and I'll just do df.drop, and you'll see that now we don't have a ticket column. Again, if I just print my df.head, which is the header plus some files, some values, so if I just see, we have the ticket column here. So again, I was confused, but if you remember, we have to use in place equal to true, because I have not assigned this value to any data frame, and this was not adjusting the values the original data frame, so I need to use in place equal to true here. So now if I just run this and run df.head, you'll see the value has been updated in the original database, and ticket column is not there in the original database. So that's how you can drop the complete column. Next, how we can deal with the null values. So I have already shown to you how we can see if there are any null values. So the values with the true are the null values, and values where the false is those are non-null values in our complete database. There are two things that I can do. I can replace those null values with some other values, or I can delete those null values, that is the rows which contains those null values. Okay, so first let us see how we can replace those null values. So for that, we'll use .fill na command, where I need to provide a value which should replace the null values. So let me first see what are the null values, which column had those null values that we want to replace. Okay, so we had age, cabin and embark. So I'll do each of these columns. I'll do different operations on each of them. So let us take the age. Since it's a numeric column, I can find the mean value of my numeric column. Okay, so what I'll do is I'll just write df age dot mean, and if I just print this value, you'll see this is the mean value for our age column. Okay, so this is the mean of our age column. Now I can use .fill na method with this particular value, so that wherever there is a non-null value in the age column, it should fill those null values with this mean value. And I also need to provide which column I am talking about. Okay, so this is the age column. I need to fill it with na, and let us see what it does. Okay, so I have provided it in the inverted commas. Okay, so this is a variable. So okay, so wherever there was a null value, this has been replaced by the mean of the age column. Okay, so that's the rule of thumb. Whenever we have numeric columns, we can replace the null values with the mean values. Whenever we have categorical columns, which is the string columns, we can replace the null values with the mode value, which is the highest amount of value which is occurred. So let us see for that cabin. So I can use the mode value for that, and I need to select the first index, because it's also giving me some other values as well. So I'll just take the mode value and I'll print that value. Okay, so in cabin, the cabin with the B96, B98, this is in a particular cell. Both the cabins are there, and this particular combination is the highest occurring combination. So what I'll do is I'll again fill the cabin column with the mode value. Again, you see I'm not using in place is equal to true, and which ideally I should use, because if I want to update it in the original data frame. But here I'm just to show you, I'm just doing it right away. So here you see there are B96, B98, these values are replaced with the null values. Okay, now if you want to drop the null values, you can use df.drop na command, where you can provide the column based on which your rows will be dropped. So if I used embarked column here, which is this column, and it has two null values, so wherever these two null values are, it will just drop all the those particular two rows with all the data in all the columns to be deleted. So if I just run this,
And previously you have seen that we had total 891 rows. So ideally it should be 889 rows now, because there will be two null values and that should be dropped. Okay, so I can just use .info command to see if that has taken effect, and let us see. So yeah, so all the rows are now 889. Great. So now we know how we can drop or actually manipulate the rows or cells with the null values. Let us see one last function, which is how we can transform those particular values inside any column based on certain conditions. So let me explain this to you. So we'll use dot apply function here. So what it will does is, let's say I have this ticket column. No, sorry, let's say I have this P class column. So what does this column contains is, it contains the ticket class of my passengers, which is the first class, third class, and there is also a second class. Let us first see all the unique classes that we have. Okay, just to confirm, I'll show you using the unique method. If you remember, we can see all the unique values inside that column. Okay, so we have third class ticket, first class ticket, and second class ticket. Okay, now my question is, the first, second, and third ticket class should be updated such that the first ticket class remains first ticket class, the second and third ticket class should become third and fourth ticket class. It is because I want to introduce a new ticket class on my ship, and that's why I need to update the previous ticket class by adding it to 1. So for that I can update using dot apply function. So I'll select my column and then I'll apply dot apply function, and then I can write lambda x, and so it will create the x variable which is iteratable for every row. Now what I'll do is, I'll do x plus 1 if x is greater than 1. That is, if ticket class is 2 or 3, it will just update them by 1 by adding 1 to it, else it will keep that x as same as before. Okay, now if I do in place equals true and run it, okay, so this function doesn't have in place keyword argument, so I'll just keep it like this, and what I'll do is, I'll just update my column P class and just update these values to my original data frame. Okay, now it's been updated. Now let me show you what this P class contains now using the unique method. And if you'll see, we have now the first ticket class, third ticket class, and fourth ticket class. Okay, so this is how we can use dot apply function as well. And there's also similar function dot transform function, which you can look up into the documentation of this pandas library. And yeah, so that's all for today. So today we just discussed the basic structures the panda contains, which is the series and data frame. We saw how we can create these series and data frames using different methods, and then we saw basic methods that we can use on our data frame, like transpose, sorting by index or the values inside the database. Then we saw how we can read the data from any particular given data set that you will do in most of your projects. Then we just saw different functions like dot info, dot head, dot tail, and dot describe to view the data in different formats. Then we saw how we can see the unique values, or we can see how many values are there in any particular category. Then we saw how we can update the values, what is the problem in chain indexing, and how we can avoid that using dot loc, which is the dot location, and dot integer location method. Then we saw how we can drop a complete column and how to handle the null values. We saw there are two methods, which is the dot fill na, which will replace the values with the required value that we want for both categorical and numerical columns. And then we saw how we can drop the null values if we want to. Okay, and at the end we saw how we can use this apply function for our needs. At the end, I also wanted to show you how you can save your data to some CSV file. Okay, for that I can use .to CSV. So whatever new data that I have right now, I can just save it with .to CSV function, and if I run it, you'll see that new file will be created with the name of trainnew.csv. Okay, that's how you can save your data file at the end as well. So that's it for today, guys. If you found this content helpful, please hit that like button and do subscribe so that you never stop learning with more such videos.
By the way, knowledge without practice is useless. So if you want to apply your knowledge on whatever you have learned till now for a data analysis project, you can watch this video right here, where we will go step by step and complete an end-to-end data analysis project together. So I'll see you right there, and thank you for watching.